I've worked in quite a bit of natural language processing over the years. So I first met Peter in the bibliographies workshop. But for today, I've picked up on the biodiversity theme from Sophia to show you some examples of the issues that we've been tackling. And so far, this is conventional. I do not invent my own tools. This is a screenshot of BRAT, which you've already heard mention of. That's what I use for creating my gold standard data. This is a slightly complicated task, and that I'm trying to break down taxonomic names, so the names of living organisms, by their rank. So not just saying it's the name, but what are the components of the name? And that's wonderful in modern literature because we've got standards, international conventions and zoological names, botanical names, etc. In the historic literature, tough. Those conventions did not exist. Names are whatever they came up with, and boy, could they be creative in how they devise names. So this is me creating gold standard data. There's OCR errors in there and so on. And yes, we do have a lot of OCR errors. Two reasons. One, this is potentially very old data. It's still incredibly valuable. If you're a climate researcher, you've got fantastic records from 100 years ago, 200 years ago. You know the provenance, you know it's good quality recording. You can find out what climate, habitat, indicator species, where they were 200 years ago. That gives you a fantastic baseline for your studies today. So this is really vital literature anyway, besides the taxonomists who always have to go back to the source description of a species when they're talking about a species. You have to, the species concept must be consistent and rigorous across your research. So you're always talking about the same type of beastie when you come to or plant or fungus, when you come to reclassify it. And it's all quite dynamic taxonomy. It's not a done set science. It keeps changing. Things get reclassified. This is a beetle, Attalabus. So here are some examples of what the OCR has recognized as Attalabus elsewhere in the text. So far, so conventional. This is my first twist. This text is available through the BHL, Biodiversity Heritage Library. You can play with it yourself. It's from the Smithsonian in Washington, and they outsourced their digitization to Internet Archive, who splat everything through a straightforward, this is North American English. So, of course, it screws up anything Latin in there, and all the formal descriptions are in Latin. And in North American English character set, you do not have the AE ligature. In other words, the OCR will never, ever give you a correct rendition of that. In this case, it's a specific epithet. So that's our starting point. 100% wrong. So how can we start pulling everything together? The other interesting thing in biological texts, of course, is you've got the male symbol and the female symbol. They're not in the character set, so they are never recognised in the text as well. And of course, you're full of terse comments. So this was a male specimen. You never write male. It's the symbol that you use. Or, of course, if it's plurals, females, you don't write females, you write two female symbols next to each other. Somewhat better. This is from the Natural History Museum, London. Of course, aware of this issue. So, again, a book on beetles. So, we've got on your left the beetle family and subfamily names that are going to be mentioned in this book. These are all grabbed from the introductory couple of pages of the book, and it's telling you what it's about. And because it's an old-fashioned book, all those names have got a ligature in them, AE somewhere. The modern name, it's 2 characters, so it's not an issue in born digital or modern literature, but it does matter in getting the names out of this older text. And sadly, even though an appropriate OCR engine was used, it's not found a single one of those 24 ligatures. And you see there's the pattern of errors. Reasonably enough, about half, it's broken into AE. Interestingly, 5, the OE ligature, and there was 1 example of OE ligature in the document, and it got it right. So it all gets a bit hit and miss as to, what are we dealing with here? And I've had various conversations. I've worked with BHL over many years, and users of BHL, and people have complained about the OCR. So I dug a bit deeper and said, well, actually, it's not always that bad. And this is one of my demonstrations. Sciurus is squirrel from Central America text I was working on. And if you just glance at the OCR output, like a human skimming a book, you're going to look at headings, indexes, table of contents, and in other words, isolated words. And they're going to be typically maybe a larger font or a heavier weight. It's something different from the body text. And there, as you can see, in my very short sample, this is more anecdote than proper scientific research, but there were 7 loose words, and the OCR only got the word correct once. But in the body text, of course, the OCR was building up its confidence, if I can anthropomorphize the OCR engine. But there are all these words like what and so on. It was getting right, so it's getting very confident I can recognize these characters. So sciurus, even though it wasn't in its dictionary, it couldn't validate that this was a correct word, within the body text, because there was enough context for it, it was getting quite a high accuracy. I mean, that's about 96% or something. So is it bad OCR? 96% accurate. So, but finally with a twist, in terms of resolving all these issues, again, simple example, denticulate, 11 characters in this word. And the first line here is we have 2 OCR-induced errors. The terminal character has changed. So if you're familiar with Levenstein edit distance, the number of changes you have to make to a word to transform it from one form to the other, we need to make 1 change. So hence, under the Levenstein column, we've got to 1. Ignore the other 3 numbers for the moment. You need to make 1 change to get from denticulate to denticulata, denticulate. Now, if you're trying to cluster, you find what are all these OCR-induced errors. It's an 11-character long word. Perhaps it's reasonable to say there could be 2 OCR errors. But once we go up to a distance of 2, we get something like penticulate and renticulate and geniculate. They're real words. But because of all the formal Latin-style writing, they apparently appear similar. So one of the things I did in a mad afternoon was just break down the words, slice it into 5 character segments, beginning, middle, and end. Could I spot any patterns in doing Levenstein distances and parts of words? And I've got all sorts of ideas on how I'd love to cluster and group, and that sort of thing I would like to talk about this afternoon. As you can see, the numbers get a bit crazy, so I'm not sure that's a good approach. And finally then, the final set of wrinkles. Tachys. It really should be Tachys. Oh dear, the OCR got it right. It was a typo in the original document. How do you cope with that? Pioa goes to Pika. If you can use an external catalogue of life type resource, you'll pick up that as a problem because Pioa doesn't exist. Pika is magpie. So Pioa we know is wrong. But what happens if you get Homa being misrecognized as Homo? So we go from a butterfly to humans. Humans exist. So if you put that Homo into catalogue of life, you'd say, yeah, it's valid. And potentially, because the way we reuse names in taxonomic naming, you can get, as in the second example, Pieris and Pieris, butterfly and a heather, you can get all sorts of confusions. So my thing I would like to explore is that I've done work elsewhere in concept extraction I'd like to bring in. I haven't done anything on sentiment analysis, but I can see the things there that could help in terms of resolving some of these issues. So I've got all sorts of ideas I'd love to talk this afternoon and share with what we could do with untangling some of these wrinkles. Thank you.